Okay, let us discuss about the steps involved in data pre-processing. The first step is data cleaning. The data cleaning routines attempt to fill in missing values, smooth out noise while identifying outliers, and correct inconsistencies in the data. The data cleaning process is considered as an iterative two-step process, and it includes two steps, that are discrepancy detection and data transformation. This data transformation should not be confused with the third step involved in data preprocessing. This is the step included in the data cleaning process. So we have to study two-step process, it as a two-step process, that are discrepancy detection and data transformation. We will discuss different ways of handling missing values, and we will explain data smoothing techniques, and we have to discuss about different approaches to data cleaning as a process. The missing values can be handled in different ways, including 1 to 6. We can ignore the tuple, fill in the missing value manually, or we can use a global constant to fill in the missing value. Use the attribute mean to fill in the missing value. Use the attribute mean for all samples belonging to the same class as the given tuple. Or we can use the most probable value to fill in the missing value. The methods 1 and 2 are not practical. We can't ignore the tuple. If we have many missing values, the data will be lost, or the information will be lost. So we should not go for ignoring the tuple. But fill in the missing value manually is also not practical, because we are dealing with terabytes of memory data, or terabytes of data. So it will be very tedious task for filling manually. So we can use 3 to 6 methods for filling the data missing value, but method 3 to 5 will bias the data. The filled value may not be correct. Use the most probable value to fill in the missing value is a popular strategy. So method 6 can be used to fill the missing value. And we are going to discuss different data smoothing techniques. This is used to avoid the noise. Noise is a random error or variance in a measured variable. Data smoothing techniques are used to eliminate noise. The first method we can use is binning. Okay, we will see by example. Figure 2.1 shows binning methods for data smoothing. We have a sorted data for price in dollars. For example, we have a data like this: 4, 8, 15, 21, 21, 24, 25, 28 and 34. We will partition into equal frequency bins. Bin 1 will contain the first 3 values, that is 4, 8, 15, and bin 2 will contain 21, 21 and 24. Bin 3 is used to store 25, 28 and 34. Smoothing the bin means we can smooth the bin by calculating the bin means. For example, bin 1's mean value will be calculated, and based on the mean value, the bin 1 will be replaced. So if we get 9 as the mean value of 4, 8 and 15, we will replace those values with that mean. Like that, we are replacing bin 2 and bin 3 also. Or we can smooth by bin boundaries. For example, we can either use the left boundary value, or we can use the right boundary value. Here it is considered as the left boundary value. So here we are smoothing it by the bin boundaries. Here 4, 8, 15, that was the bin 1 value. We are smoothing it by 4, that is the left boundary value, so 4415. And bin 2 is already in that form, so it will not be disturbed. So the value is 21, 21, 24, and bin 3 will be replaced like 25, and 28 will be replaced by the left boundary value, that is 25, then 34. So this is a method for avoiding the noise. So binning is a smoothing method to avoid the noisy data. Another method is regression. We can use the statistical method that is called regression for this smoothing. Data can be smoothed by fitting the data to a function, such as with regression. We can use different types of regression: linear regression or multiple linear regression. Linear regression involves finding the best line to fit two attributes or variables so that one attribute can be used to predict the other. Multiple linear regression is an extension of linear regression where more than two attributes are involved and the data are fit to a multi-dimensional surface. So we can use clustering also for doing this smoothing. We know what is clustering, so I am not explaining it again here. Many methods for data smoothing are also methods for data reduction involving discretization. So some of the methods we mentioned here will be used for the data reduction, that is the fourth step in data pre-processing. It will involve discretization. You will not understand the points very well by this slide. When we complete all the portions under data pre-processing, you can study these points and you will understand very well at that time. For example, the binning techniques described above reduce the number of distinct values per attribute. This acts as a form of data reduction for logic-based data mining methods such as decision tree injection, which repeatedly make value comparisons on sorted data. Concept hierarchies are a form of data discretization that can also be used for data smoothing. So you just listen to this slide. When we complete all the portions, you can understand what is mentioned in this particular slide. Then we will consider the data cleaning as a process. The first step in the data cleaning as a process is discrepancy detection. We want to detect the discrepancies. Discrepancies means errors or some mistakes happened. Okay, so discrepancies can be caused by several factors, including poorly designed data entry forms that have many optional fields. Okay, that is a reason for the discrepancy, or the human error in data entry, that can also lead to discrepancy. Then deliberate errors, example, respondents not wanting to divulge information about themselves. For example, the user or the customer don't like to put their phone number in their particular data. So deliberately they may make errors. For example, they will change the phone number like that. And data decay, example, outdated addresses. So these are the causes that may lead to discrepancies. We can use some tools for discrepancy detection. Some examples include data scrubbing tools and data auditing tools. And the second step in data cleaning as a process, we require data transformations to correct the discrepancies. We have identified some discrepancies and we want to correct it. So that is the process of data transformation here. For that, we can use certain tools that are data migration tools, or we can use ETL tools, that is extraction, transformation, or loading tools. The second step in data pre-processing is data integration. It combines data from multiple sources to form a coherent data store. metadata, correlation analysis, data conflict detection, and the resolution of semantic heterogeneity contribute towards smooth data integration. So the data integration process will be followed by the collection of metadata, correlation analysis, etc. And this will contribute toward a smooth data integration process. There are a number of issues to consider during data integration. Uh, During data integration, we have to consider schema integration and object matching, redundancy, and the third important issue is detection and resolution of data value conflicts. We will see what is the meaning of schema integration and object matching. It is referred as the entity identification problem. We have to identify what are the entities that has to be recorded and what attributes should be considered in a particular entity, that is for describing that particular entity. So this is also known as entity identification problem. Then second issue is redundancy. Redundancy is another important issue. This can be detected by correlation analysis. We should not have much duplicate or redundant values in the stored data. So we can identify the redundancy by using the correlation analysis. For categorical or discrete data, a correlation relationship between two attributes A and B can be discovered by a statistical test known as chi-square test. Chi-square test will help us to identify the redundancy. This is a correlation analysis test, so that can be done. A third important issue in data integration is the detection and resolution of data value conflicts. So we have to resolve the data value conflicts before we integrate the data into a single repository. Next one is data transformation. Data transformation routines convert the data into appropriate forms for mining. So this is the format changing. We are changing the format into some standard format like that. For example, normalization is a process of data transformation. By normalization, the attribute data can be scaled so as to fall within a small specific range. For example, 1:2, 1:0, 1:0, 0:0 to 1:0, etc. For example, we have very large scaled data. For example, we have 1 to 100, that is the value of age, but we have to scale it to a smaller range. For example, 1 to 10. We are scaling it to 1 to 10. That can be possible. So this is the kind of data transformation. If we need such scalability change, or we have to change the scaling of the data, we can go for this transformation. There are several methods for data transformation. The data cleaning method known as smoothing can also be used here for the data transformation. Smoothing is a kind of method for data transformation also. Or we can go for aggregation. We can do generalization of the data. For example, we can generalize to particular values. For example, if the age of a particular person is 6, we can generalize it into 5 to 10. Or if the age is 27, we can generalize it into 25 to 30. Like that. That is the generalization of the data. Or we can do the normalization process, or we can attribute construction, or we can do attribute construction. It is also known as feature construction. These are the different methods for data transformation. Next, that is the fourth step involved in data pre-processing, that is data reduction. We can reduce the data into a smaller one by using this step. Data reduction techniques can be used to obtain a reduced representation of the data while minimizing the loss of information content. Strategies for data reduction. We have to follow some strategies for data reduction. We can use data cube aggregation. Here we will study the data cube aggregation. We have already discussed with the multidimensional data model, so that is known as data cube aggregation, or we can use attribute subset selection, or dimensionality reduction can be done, or numerosity reduction can be done, or the other method or other strategy is discretization and concept hierarchy generation. Discretization and concept hierarchy generation will be handled in the next session, because the syllabus is have that particular topic separately, so we will discuss it in the next session. We will discuss the 2, 3 and 4 in this particular session. Attribute subset selection. Basic heuristic methods of attribute subset selection include the following techniques. We can select the attribute subsets by the following techniques. One is stepwise forward selection, or we can do stepwise backward elimination, or we can use a combination of forward selection and backward elimination, or we can use decision tree induction for selecting attribute subsets. This can be explained with this figure. This is a greedy or heuristic methods for attribute subset selection. Here we have forward selection, backward elimination, and also decision tree induction method. Let us see by example. We have an initial attribute set. In the particular data set, we have attributes like A1, A2, A3, A4, A5 and A6. Initial reduced set, we don't have any attribute. That is the most reduced set. That is, we are not considering any of the attribute. Next, we can consider for one of the attribute, that is A1. And we are considering another attribute, that is A1, then A4 we are considering, and finally we are considering only 3 attributes among the 6 attributes in the initial set. Okay, so that is the method followed in forward selection. This attribute selection is based on some criteria that we will discuss later, but this is the process of forward selection, that we are considering initially a null set, then we are considering a single attribute from the initial attribute set, then we are considering one more, then another, like that we are coming to the reduced attribute set, that is A1, A4 and A6. And example for backward elimination. We have initial attribute set. The same example is described here, and initially we have all the attributes. Then we are reducing 1 or 2 attributes from the given set. Finally, we get a reduced attribute set with only 3 attributes. This is known as backward elimination. And decision tree induction method can also be used, and we are choosing a particular attribute based on some criteria. Here we are choosing A4, and if A4 is yes or no, we are choosing another attribute, that is called A1, and A1 is yes, we are having class 1, and A1 is no, then we are grouping it into class 2, and we are considering attribute A6 if the A4 is no, and A4 is we are again considering whether it is yes or no. Then according to that we are classifying that. So we are getting only 3 attributes among the initial attribute set. So this attribute selection is happening like this. This method is known as decision tree indection. Okay, these are the various methods for attribute reduction or attribute subset selection. Then next one is dimensionality reduction. Data encoding or transformations are applied so as to obtain a reduced or compressed representation of the original data. So we have to use some encoding methods or transformations, and we can have a compressed form of representation of the original data. For this we are using dimensionality reduction. Two popular and effective methods for dimensionality reduction is wavelet transforms and principal component analysis. The principal component analysis is also known as PCA, which is a very common or popular method for this dimensionality reduction. Or we can do the numerosity reduction. We can reduce the data volume by choosing alternative smaller forms of data representation. Techniques of numerosity reduction can indeed be applied for this purpose. These techniques may be parametric or non-parametric. For parametric methods, a model is used to estimate the data so that typically only the data parameters need to be stored instead of the actual data. So instead of actual data, we may represent some data parameters. This is known as parametric method. Example, log linear models which estimate discrete multidimensional probability distributions. Or we can use non-parametric method. It is for storing reduced representations of the data, include histograms, clustering and sampling. For representing the data, we can use some representation models or graphical representations like histograms or clustering model or sampling can be used. This is an example for sampling. This is used for reducing the data set. For example, in the above figure, we have 8 transactions, transaction 1 to transaction 8. We can get samples, each having 4 tuples. That can be one method, or we can use a cluster sample. For example, we have see the second figure, we have T1 to T100, then 101 to 200, like that we have 1000 records, transactions, and from this particular cluster we are choosing only 2 clusters as sample. For example, transaction 201 to 300, and we are choosing transaction 701 to 800. So these are known as cluster sampling. Or we can use stratified sampling. Here you see based on the age we have several transactions here. Youth we have 4 transaction records, and middle-aged we have 8 records, and senior we have only 2 records. Based on the proportion, we are choosing for youth cases, 2 youth cases. That is, we have 4 samples here, and we are choosing only 2. And we have 8 samples of middle-aged, so we are selecting 4. That is the half of that values are selecting for as the sample. And senior we have only 2, so we are selecting only 1. So this can be done. So in any method can be used for the sampling. These are some examples for doing sampling. So this sampling is used for data reduction. So there are different methods for data reduction, and we have to study one more method, that is data discretization and concept hierarchy generation, We will study it separately because we have that topic separately in your syllabus. But it is part of this data reduction. So we have studied 4 different steps involved in data pre-processing. One is data cleaning, next one is data integration, then data transformation and data reduction.